Okay, so there are different counting techniques that we can apply to determine the number of outcomes in our sample space, or actually what our sample space is. One of them is a tree diagram, and I think in the homework it'll have a couple of examples that'll have some tree diagrams in them, so I wanted to show you how to draw a tree diagram. So let's say we want to know the sample space of drawing 2 M&Ms. Okay, out of a bag that contains 5 blue M&Ms, 3 red, and 2 yellow. So how many M&Ms do I have total? 8, 9, 10. I have 10 M&Ms, right? Okay, so I want to know the sample space for drawing 2 M&Ms. Okay. So when I draw my first M&M, we call these nodes on our probability tree. Okay, so when I draw that M&M, it could be a blue M&M, right? Or I could get a red M&M. These are my possible things that I could get. Or it could be a yellow M&M on my first draw, right? So this is what my tree looks like. I could have blue, red, or yellow M&M. Okay, and this is my first draw. These are called branches in my tree. On the second draw, again, if I drew a blue M&M on the first draw, I can still get a blue M&M on the second, or I could get a red M&M on the second, or I could get a yellow M&M on the second draw. Okay, and I do the same thing for the second branch here because, okay, another situation could have been I have a red M&M on the first draw, I have a blue M&M on the second, or a red on the first, a red on the second, or a red on the first, a yellow on the second. Okay, another situation is if I have a yellow on the first draw, I could have a blue on the second, a red on the second, or a yellow on the second. Okay, when we draw these probability trees, sometimes they'll start up top and go down like this. Okay, same thing. Okay. Okay, so to show my sample space, though, I start at my initial node here, and I start and I follow it to the end of each branch. And so that's one possible outcome in my sample space would be blue on the first, blue on the second, or BB. Okay? Or, oops, it took my line off. Sorry about that. Or I could have a blue on the first, a red on the second. Right? So that would be blue on the first, red on the second. Or I could have blue on the first, yellow on the second. Right? So that would be blue on the first, yellow. And I keep going. So red on the first, blue on the second, red on the first, red on the second, red on the first, yellow on the second, yellow on the first, blue on the second, yellow on the first, red on the second, yellow on the first, yellow on the second. Okay? Now these events are not equally likely. So even though I have 1, 2, 3, 4, 5, 6, 7, 8, 9 possible outcomes, to get 2 blues, it's not 1 out of 9 because these are not equally likely because I have different numbers of M&Ms, right? So what I want to do is fill in my probabilities. What's the probability Okay, what's my probability of getting a blue on the first draw? Well, I have 5 out of 10 M&Ms, or, 5/10, right? So then what's the probability, I'm just going to make some room here, of getting a blue on the second draw? Well, this is the probability of getting blue on the second draw given I got blue on the first draw, right? So that's assuming that this already happened on the branch. Okay, so if I got blue on the first draw, that would mean I only have 4 blues left and 9 M&Ms. So my probability then would be 4/9 on the second draw. Does that make sense? Now I can do the same, calculate the same thing, okay, for these other branches here. So for the second one, if I want the probability of getting red on the second draw given blue on the first draw, okay, same thing is true over here. Well, actually it's not, right? This time I drew out, oh, I'm sorry, yes it is. We drew out a blue on the first draw. So now I want to know the probability of getting a red in the same situation. So I have 3 now out of 9. Because I took that, I'm just assuming I took that blue one out on the first draw, right? And we do the same thing for this next branch here. Probability of yellow on the second draw given blue on the first draw. Okay, now it would be 2 out of 9. Does that make sense? So then this would change here. Okay, for this second branch, probability of red on the first draw is 3 out of 10, right? But now on the second branch here, the probability of getting blue on the second draw, given I had red on the first draw. Okay, that would change. That's assuming I got red on the first draw, so now I only have 2 reds left and 9 M&Ms left. Okay, again, this is assuming I didn't put the M&Ms back in, right? So now, getting a blue on the second draw, given I took out the red, would be 5 out of 9. Okay, this gets a little bit confusing. So now, I'm going to erase this just for now. If I'm calculating the probability of blue on the first and blue on the second, this BB thing, what I'm doing is I have to start at the initial node and follow the probabilities through. So I'm going to take this probability and multiply because blue on the first and blue on the second. So I would have 5/10 times 4/9. Okay, so I'm not sure the homework gets into this much detail, but I wanted you to understand the tree diagrams and what they look like. Okay, some of the counting formulas then, we have what's called the multiplication rule. And then we also have what are called permutations and combinations. And I'll do another one to talk about.